To all, I am Assistant Professor Kute Akshada from S&D Engineering and Research Center, Evla. Welcome to online lecture series. Today's topic is application of infrared spectroscopy. First, qualitative analysis. In qualitative analysis, identification of substances. To compare spectrums, no two samples will have identical IR spectrum. Sample and references must be tested in identical conditions like physical state, temperature, solvent, etc. Enantiomers cannot be distinguished. The fingerprint region 1200 to 700 cm inverse. Small differences in structure and constitution of molecule. Hence, this region helps to identify an unknown compounds. These are the graph of infrared region. Transmittance versus wavelength. Computer search systems. Never infrared instruments offer computer search system to identify compounds from stored infrared spectral area. The position and magnitudes of peaks in the spectrum is compared with profiles of pure compound stored. Computer then matches profile similar to that of the analyte the resulting display. Strength of bonds. As the stronger bonds absorb infrared at a greater wave number, the relative strength of various bands in the molecule can be understood. Identification of organic compound. From the matching of infrared spectra of unknown sample and a known organic compound, it is possible to identify the unknown organic compounds. This is the graph. Absorbance versus wave number. Second, determination of molecular structure. Determination of molecular structure used along with other spectroscopic techniques. Identification is done based on position of absorption bands in the spectrum. Example, C double bond O at 1717 cm inverse. Absence of band of a particular group indicates absence of that group in the compound. Next, studying progress of reactions. Observing rate of disappearance of characteristics absorption band in reactants, or the rate of increasing absorption bands in the products of particular product. O single bond H is equal to 3600 to 3650 cm inverse. Then C double bond O is equal to 1680 to 1760 cm inverse. Detection of impurities. Determined by comparing sample spectrum with the spectrum of pure reference compound. Example, ketone impurity in alcohols. Detection is favored when impurity possesses a strong band in IR region, where the main substances do not possess a band. Isomers. Since infrared absorption of a trans isomer is weak and the cis is stronger, it can be concluded whether the organic compound is having cis or trans structure. Next, structural information. Since molecules having symmetrical structure about a bond have negligible absorption in the symmetrical mode of stretching, therefore structure of molecule can be assigned. Isomerism in organic chemistry. Geometrical isomerism. Trans isomers give a simpler spectrum than cis due to symmetry. Conformers identified with the help of the high resolution infrared spectrometers. Example, ethanol. Normal OH is 3636 cm inverse. Weak band 3622 cm inverse. Tautomerism. Existence of two or more chemical compounds capable of interconversion usually by exchanging a hydrogen atom between two atoms. Example, thicarboxylic acid. Functional group isomerism. Isomerism shown by compounds having same molecular formula but different functional groups. Example, diethyl ether CH3O CH3 and ethanol CH3CH2OH. OH is equal to 3500 to 3100 centimeter inverse. Next, application of IR spectroscopy to inorganic complexes. High modes of vibration, since they contain more than 5 atoms, hence minimum 10 modes of vibration. Lower symmetry of complexes due to formation of ligand and polynuclear complexes. Formation of chelates. Large number of new bands appear. Next, shape of symmetry. If nitrogen dioxide NO2, if linear, only 2 bands should be present. If bent, 3 bands should be present. 9. Identification of functional groups due to presence of functional group region. Example, 2-methyl, 2-propanol and 2-butanol. Next, monitoring environmental pollution. A polluted air can be taken in a 20 cm long tube for identification and finding quantity of the pollutant by IR spectroscopy. Water pollutants can also be analyzed by this technique. Measurement of ethanol in the breath can be easily detected by IR spectroscopy. Which device is called intoximeter. Study in reactions. The kinetic of organic reactions can be studied by IR spectroscopy. The tautomeric convergence, isomeric convergence, other equilibrium reaction can be studied with spectroscopy. Percentage of crystallinity of polymers. This can be studied with IR spectroscopy. Example, nylon crystalline has IR absorption at 935 cm inverse and amorphous nylon has the absorption at 1235 cm inverse. 10. Presence of water in sample. If lattice water is present, spectra will contain 3 characteristic bands at 3600 to 3200 cm inverse. Thank you.